Hello, everyone. My, my name is Filip Hráček. I'm a Flutter developer advocate at Google, and this is things you didn't know about Flutter. So first things first, so Flutter is a mobile development SDK. It's a toolkit for building apps for iOS and Android, right? And when I learned that I will be able to present here in Prague DevFest, I was really excited. But then I realized that I have a big problem because many people probably know a bit about Flutter already. As in, like, you probably... So actually, how many of you at least like read an article about Flutter? Right? Yeah, so like 75%. So that probably, if I just made my usual intro talk, you would be all bored and you know, things would be bad. So I thought, what I'm gonna do is I'm going to prepare things and like little tidbits of information that are interesting for everyone. Even though if you're an expert developer, you will find some things that you'll learn. If you're a total beginner, hopefully you will still be able to find out about things that are interesting. Anyway, I found them interesting, right? So the next thing is, what the hell am I using for slides, right? So that was, while I was having brilliant ideas about the content, I thought, wouldn't it be cool if I made the slides in Flutter? So that's what I did, and then like an hour later, I was like, oh my God, what am I doing? Because obviously I had to like recreate everything from scratch, but I pulled through, and so now this is actually like, this is not Google Slides or anything like that. This is an actual Flutter app, which actually I can show you works on both iOS and Android, and I will be presenting from that. And that gives me a good, like a couple of good options. For example, I can modify the slides while we're talking. I can do live coding demos, which I will do with the slides that I'm presenting. So that's going to be, I think, interesting if it works. Anyway, I think this is probably the first time anyone does have slides in Flutter, and probably maybe even the first time anyone has slides in an actual mobile app. So you know, we may be part of history. I'm not sure. All right. So things you didn't know about Flutter. One thing that you may know about Flutter is that this mantra of Flutter that everything is a widget, right? So one thing that you might not realize is that even apps are widgets. So you can have apps within apps. So that's what I have here. I have the regular, like, kind of getting started app here in my app, in my slides. I can work with it normally. And obviously, I can do all the things, like I can change things on the fly. So DevFest. And when I save, it will change everything right there. It's not just about constants, it's also about logic. So I can actually say, you know what, the counter will go down instead of up. So I can do this. And it's still, as you see, the state is still there. So if I was building an app, I don't need to go back to the beginning and then like click through everything. What's even cooler, I think, is that I can actually crash the app. So I just put null here. It's going to crash, but then I can fix it, and I'm back, and it still has the state, which is pretty cool if you make bugs, which I do. So that's great. So this is like the 5-minute intro to what it is like to build with Flutter. What other things you didn't know about Flutter? So for example, most code in Flutter was written in 1842. This is a true statement, by the way. And by 1842, I mean the building 1842 on North Shoreline Boulevard, so that's where the Flutter team is, or actually was. Like a month ago, we moved to somewhere else. But it's still the case that if you go to GitHub and look at the Flutter source code, most of the code was written in 1842. building. All right, but more seriously, where does it come from? Like, what is the history of Flutter? And that, I think, is pretty interesting, and many people don't know it. It actually started in Google Chrome. So there was this little project, basically just an experiment in Google Chrome. Google Chrome, as you probably know, is this web browser. They have been doing this for years and years, and they've optimized the building of and rendering and laying out of web pages for years. So that's great, and they made a really good job of doing that. But then they realized, okay, so what is our biggest constraint when we are trying to render web pages? And that is, they are web pages. So what if we remove, and that's a crazy idea, but what if we remove all the constraints that web pages have? So like DOM, CSS, maybe even JavaScript, and like still use all the cool things that we built for Chrome so that it's fast and performant and all that, right? So they hacked on this for a week, and in a week, just by kind of pulling out things that they thought might be slowing them down, like, for example, DOM, they made it significantly faster. And it's not surprising that it's faster if you pull out DOM, but it's surprising how fast they could do that in a week. So they thought, okay, so maybe we have something here. What if we just like use all the things that we know about layout and all these things and just apply them to a problem that does not have this constraint of building web pages and HTML and CSS and JavaScript, right? And so that's what it went to. So they asked this question, and they said, let's just pull out everything, and let's create something that is obviously not a web browser anymore, but is using all these cool technologies that we've done. So that's why in Flutter, the rendering engine is based on Skia, which is the rendering engine for Chrome and Android now and all these other things. The text rendering engine is actually the Chrome rendering engine. So they just put that in. But the rest of the things are Flutter. So how, like if you're building a Flutter app, how does that look like? What's the architecture of that app? It's very different from what most people expect when you tell them that this is a cross-platform application framework, right? This is not something like, oh, we're going to have like a platform app, and then we're going to drive it from somewhere else. It's not a web view that you're building and then like communicating with the underlying platform. This is actually, you will take your code and you will compile it with the framework to machine code, and that machine code just like sits right on the operating system. It's like, if you're coming from Android, it's like an NDK app, right? So I said native, and there are two definitions of native right now in computer science, especially when it comes to mobile development. The first definition, the original definition of native, is it runs natively on the CPU, on the processor that you're using, right? So it's like ARM code for ARM. The opposite of it is any VM, like JVM or basically any other VM. So that's the original definition of native. But like especially in mobile development, you also have the other native, which means basically the platform things. Like I'm using UIKit on iOS, or I'm using the Android Java framework on Android. And so Flutter is the first native. Flutter is compiling really to native machine code. It's not the other native. It's not using unless you really want to, it's not using the native views and native frameworks, the platform frameworks, right? That's, again, in contrast with other tools, like, for example, Xamarin or React Native. In React Native, native in React Native means the other thing. It doesn't mean that it's compiled to native machine code. It means that it's compiled to, well, it's just JavaScript VM running native views. All right, so yeah, to reiterate, this is really compiling to machine code. This is not a web view, nothing like that. This is a machine code thing, and it paints all these things. So what you see here, none of this is like Android view. It's actually painting straight to OpenGL or Vulkan, depending on the capabilities of your device. So machine code and OpenGL and Vulkan. This is really important because many people don't get this. In this case, Flutter is kind of like a game engine, but for apps. If you think about game engines like Unity on Unreal, they will also compile to machine code, and then they will do their own rendering on OpenGL or Vulkan, and then they will they can communicate with things in this platform like GPS and all this, or notifications. But most of the rendering is done by them. So what does it give us, right? So for example, this is like almost like an app, like a small app. And because we're on Android, you can see that things are behaving like on Android they should. So the scrolling behavior is like on Android. The overscroll behavior is this like, I don't know if you see it, it's this like blue thing. And then the title is on the left, right? What I can do is I just go here and I override this behavior and say, imagine that you're on iOS, Flutter. And now I'm on iOS. Now, like, even though I'm running in Android, I'm actually like doing things as if they were on iOS. And that's just inherent in the platform. The platform doesn't care. It just makes it so that it like automatically looks like Android if you're on Android, but it doesn't need to be. That also means that you can do crazy things, like this is not an animation. I mean, this is an animation, this is not a GIF or a video. This is actually run like 60 frames per second, right? This one is also an like 60 frames per second rendered thing that is made in Flutter. So you can go really crazy. But you could be asking, why this way? Why would you, like, if you are trying to build apps, why would you do them in a way that you're building basically everything from scratch using OpenGL? So the reason is, if you look at top apps today, you will see something like this. They will look very custom, right? So if you look at the Uber app on iOS and Uber app on Android, they will look basically the same. They will have some like font differences. The scrolling will be a little different, but it's not using the platform views. It is using the platform views, but not the default ones. It is very custom branded. On the other hand, if you look at two Android apps, like Lyft Android app and Uber Android apps, they're basically like super different. They're not very close to each other. And so Flutter sees this and says, OK, so how do we make it very easy to do something very custom that runs on both Android and iOS? This has happened before. If you remember, maybe you don't, but I remember 15 years ago on the web, if you went to a web page and there was a button on the web page, that button was rendered by the operating system. So if you went to like Google search, that button, like the Google search or I'm feeling lucky button, was actually like rendered by the underlying platform, and it looked like a macOS button or a Windows button or a Linux button. Not anymore, right? Like if you look at basically any page today on the web, they are all custom, and it's like, of course they are. Like you don't want to see a Windows button on a web page. So this has happened before. Another thing that people kind of don't realize how big a difference it is debug versus production, right? So I think I don't know if I showed you. This app is, as I said, like it's running on a mobile phone, right? Here it's running in production because I said so, but. What we see here is, as you can see, there's a debug thing here. It's running in debug mode. And these modes are like very different in their implementation, but in actuality, they are like the app behaves the same. But debug mode is what gives you the hot reload functionality. So it's JITted, so everything is just in time compiled. You can remove blocks of code. You can add things to it. It's just like you can debug, obviously, like very deeply. You can attach breakpoints and everything like that. That's debug. It's a little slower, though, than the normal mode. And that's to be expected because it's just in time compiled, and it has all these checks and everything like that. In production mode, that's the mode where you actually compile to machine native code. And obviously that means that you cannot do hot reload, for example. But it's also what you will probably ship to your users, not the debug app. So if you see lags here, like you will probably see them, that's not the actual like performance of Flutter apps. The actual actual Flutter apps will run much smoother than in debug mode because they're actually compiled. This is again different from many other cross-platform frameworks because you have that developer experience, and yet you have pretty fast execution in production. Okay. Composition over inheritance. Most people here probably know what that means. It's basically, it's this advice of not using inheritance too much. In object-oriented design, it's very easy to kind of go overboard and say, you know what, I have this button, and then I have this, like, I don't know, icon, and both are clickable. So I will have this clickable class that I inherit from, and then, but the button is also like rotatable, so I will have another class that I also inherit from that is rotatable, and so on and so forth, and then it's just crazy and everyone is crying. This advice, composition over inheritance, says, you know what, why don't you just not inherit that much, and if you want something to be clickable, just have an object that is either wrapping around or is inside the object that you want that behavior for, right? So instead of like having attributes to everything and then like having these huge classes that inherit from everything, you will have just a simple class, and then when it needs a behavior, you either wrap it in an object or have that object inside it. And so it's like you're reifying attributes. Like if something is clickable, it's just like, instead of thinking about it as an attribute, you will say this is an object. The click, like the gesture detector, we would say in Flutter, is an object that can wrap that widget. And so anything that you click, or that widget that you click, will get that behavior, that it's clickable, right? In Flutter, because everything is a widget, we have that idea of extreme composition over inheritance. Basically, things that you wouldn't think are being able to compose, or would you think that are definitely attributes, are not. In Flutter, almost everything is a widget. It means it's an object. So let's go to code here, and let's close this. And then I will go to my slides. And where is it? OK. So this is the slide of extreme composition over inheritance. It's a widget that doesn't have anything in it except just the text. Like, it's a pretty dumb widget that doesn't have like rotation in it. It doesn't have click in it, or padding even, right? So if I want it padded, I'm just adding padding around that. And that's pretty, like, now I have padding. And the widget itself doesn't know. It just like gets that, oh, I'm here, and now I'm a little smaller. That's OK. I'll just like render in that smaller area, right? What about things like rotation? I can do transform rotate and an angle of, obviously, in radians, right? 2 something. And now it's rotated. It doesn't need to know that it's rotating again, right? Like this is done above it. So you could do a bunch of these things, and you don't need to have everything inside the widget. It's just composed. So you can compose things. We could make this clickable now. We could make this many other things. OK. This brings me to the mantra of like only one code path. The Flutter framework is kind of declarative, it's reactive, which means that you never say, hey, widget X, move to the left by 20 pixels. No, instead, what you do in Flutter and other reactive frameworks is that you say, you know what, this immutable tree of widgets, I just want to modify it, and then I run the build method, and it will kind of re-render everything from scratch. So I just say that widget is now 20 things to the left. Now rerun everything from scratch and see as if I was running all the constructors from the beginning, right? In non-reactive frameworks, what you almost always have is two code paths. One of them is the constructor that says, okay, so this is the state, this is how I will create my app, and this is how I will put it together. And then the other code path is, oh, someone clicked something or something changed. This is how I imperatively change it now, or like proactively change it. And you have to have both of these in sync. And as most of you know, like if you need to have things in sync, you will fail sooner or later. And so many things are, you will often see them that, for example, in Android, for many years, it was the case that if you just started doing something on a screen and then you rotated the device, it would crash because someone didn't think about the possibility that something was like null at this point because they only see that one code path and not the other, right? And since mobile phones are more and more like they have all these sensors and all the apps are always like getting live data from everywhere, you can't really tell that this is going to be that golden code path. You will always need to make sure that it's always correct. So this is like a list view item that is actually, I changed the physics, so this will just scroll forever. And if I change the orientation of the screen, it will just scroll. Like it's not going to do anything. It's just scrolling and scrolling and scrolling, right? All right, so yeah, so you're kind of building from scratch every time. You're kind of creating these things as if you were constructing them. And even if it's like, oh, you rotated the screen and it still is scrolling, that's just from the perspective of the framework, it's as if you just created the app from scratch. Nope. OK, so how can this be fast, right? Like if you're an engineer, you look at this and you say, OK, so this is crazy. Like he's creating all these widgets basically up to 60 frames per second. That's crazy amount of memory. That's crazy amount of CPU and like garbage collection. That must be happening, right? So the answer to this is that there's no easy answer to this. There's many little things that Flutter does. For example, because it has an immutable tree of widgets, it can be really smart about like what to actually rebuild, right? So for example, if you change something, like before I change, I think the name of the or the title of the little app within an app, it will look at that and will, okay, so I need to redraw, but all these other widgets are still the same, so I don't need to redraw them, right? So it will just like, because when a widget in an immutable tree is the same, then any widgets below it are obviously also the same. So that's why like it can really prune the tree traversal if it wants to. Another thing is that Flutter is built with Dart. Dart is the underlying language, but also the platform that is doing the ahead of time compilation. Dart is really good at allocating and deallocating small objects fast. So it has a generation garbage collector that says, okay, most things in modern UI frameworks are very short-lived. So if you allocate 1,000 things at like every frame, it will not like do all these crazy things like malloc and then deallocation and all these things. It will just say, okay, so I'm putting this here, and most of these, like 99% of these, will get swiped the next time in the next frame, and that's okay. So it's also how the underlying technology can help. So talking about Dart. Dart is pretty well versed for this. First of all, it has the JIT compilation and ahead of time compilation, and both of them are pretty top notch. So you can have the hot reload thing, and also you can have a fast app that starts up really fast. You have all these things about like how fast you can allocate small objects, but also UI development is often based on streams and things like this. And Dart is, and this is actually a quote from Eric Mayer, the guy who built C#, and he says like, Dart is right at the top of my favorite programming languages, blah, blah, blah. It supports all 4 essential effects of programming, meaning that there's a language level support of returning one object that's just normal functions, right? Then returning an iterable of objects, that's a generator, like if you're coming from Python, you know generators. Then returning an asynchronous object, that's future or promise if you're coming from JavaScript. And returning many asynchronous objects, that's a stream. That's a stream. And this is all, why am I clicking here? So, okay, so let's see how that works in practice. This is a stream builder. So this is the async generator demo, right? So that's the blue thing over here, and it uses a stream builder. Stream builder is a widget again, and stream builder is a widget that takes a stream of things and it will just rebuild anytime there's a new value on that stream. And as you can see, all this does is just some kind of like, rendering things like I want this to be light blue and blah, blah, blah. And then I just take the data coming from the stream, I convert it to a string, and then I just show it here. And I start with 1, so which is why there's 1 here, right? And I'm listening to this guy, my async generator. My async generator is a method that is an asynchronous generator. So I can do things like, okay, so I have an n of 1, and I want to do an infinite loop of not true. And in that, I want to just increase n, yield n. Again, like people from Python know what I mean. And then wait for something like a second, right? So what happens now, if I click Save, it will count to infinity from 1 forever, right? So it's pretty easy to do these things that are pretty hard otherwise. Isolates. Dart is a single-threaded programming language. That just means that in one isolate, in one kind of like context, you only need to worry about a single thread. You will still have futures and asynchronous programming and everything, but there's just one single thread. Sometimes you need a second thread, right? Like you want to have a background execution or something like this. And in Dart, there's Dart tries to shield you from like all this craziness about threads using isolates. Isolates are, I think it's a concept coming from Erlang or something like this, and it's basically this idea of a totally separate execution context which can only talk to each other using messages. So that's an isolate. So you, like every Flutter app has an isolate that you're like the main isolate where you're doing all your work, but you can also spawn other isolates somewhere else. Here I have a Fibonacci calculator. So like, it just, wow, that's taking a long time. What's happening? All right, anyway, so it's taking a long time to calculate 11, which I'm not sure what's going on. But the demo was about, I can still, even if it's calculating in the background, probably something horrible happened in the emulator, I can still use this just right. Like this is in a different isolate than, oh, wow. OK, so let's see if that's always does this. OK, so when I tried this before, it was like sub-second, but all right. Anyway, as you can see, The emulator has some problems with computing the Fibonacci number 18, but it doesn't really affect the experience of the app. I can do all these things, and it just works, right? Okay, widgets. I said before that everything in Flutter is widgets, so I'm just going to go through some pretty useful widgets that you might not know about. So first of them is animated container. In mobile apps, you will often do things that change this, like the layout of the app, and some things will get bigger or have bigger padding, or they will get somewhere else. Animated container is one of the widgets where you just say, you know what, now this is a different width or a different padding or something like this, and it will just animate between it. You can give it curves. So for this one, I gave the kind of like this like elastic curve. So you can see that it's doing that, and that's basically for free. Like I just said, you know, whenever I click, I want to like change some parameters, and I get this like nice animated thing. Similar to animated default text style, if you wrap this widget around something and then you change things, it will slowly animate between different text styles, right? So I can do this, and I don't need to worry about the linear interpolation and all this. And again, this is done with a curve, so I could have a kind of crazy curve if I wanted to. Gesture arena is my favorite. In mobile apps, you will often need to have different gestures, right? Like swiping and tapping and double tapping and long pressing, right? For that to work, if you ever have an app that has a double tap and a single tap in it, then the single tap needs to wait to make sure that it's not a double tap, really, right? Like if you would just like, the user clicked once, and if you immediately say, oh, that's a single tap, then the double tap would never happen because you just have to wait for it, right? So there's this you can have many different gestures, and you still want to make sure that all of them have the chance to kind of win, to get the user and to like say, okay, I'm a double tap and this is what the user just did. And on the other hand, you don't want to wait the maximum amount of time of any gesture to be completed, right? Because otherwise, you would like every single tap would take forever, because the double tap would be like, hey, I'm still here. I don't, you know, maybe I'm the one that the user needs to do or wants to do. So Flutter has this concept of gesture arena, which is really like, you can imagine it as an arena. Whenever someone clicks the surface, it will find out who are the different gestures that are interested in this click. And then if there is just one, it enters the arena, like a single tap enters the arena. There's no one else. Okay, I win. I'm going to like do whatever I want. I'm the gesture that the user wanted, right? But then if there's a single tap and a double tap on that same widget, again, the gesture arena is created, and the single tap comes on, and the double tap comes on. And so they look at each other, and they're like, okay, so we need to wait now. And either the second tap comes at some time, and then the single tap says like, oh, okay, I'm gonna, you know, this is not me, or the second tap doesn't get there in a allocated time of like maybe 500 milliseconds, and then the double tap says, okay, I'm off, and you win, right? And this is just for single tap, double tap, but you can have any number of like zooms and pinches and all these things that all have a possibility to kind of fight each other. And what's cool about this is actually like, even if you come up with some crazy gesture, a solution for tapping or like zooming, that you can still create this gesture and then play in the arena and say, okay, now I'm winning or now I'm losing, right? So that means that, for example, here, I don't know if you see it, but I can just click, and that's basically instantaneous. It still needs to but this one is actually looking for both a single click and a double click. And if I click, see, it takes time. Now imagine that if everything on your app would take this much time just because you used double click somewhere, right? Okay, refresh indicator, now I don't have that much time. So refresh indicator is really simple thing that just like I want to show you the code for it. Refresh indicator slide. That's just basically this. You have a widget that's a refresh indicator. It has on refresh, and then it has a child, and that thing will rebuild any time that you want, right? Safe area, you have notches everywhere now in mobile apps. You want to make sure that that part of your app is definitely visible and not under some kind of notch. You just wrap it in a widget called safe area, and now that will make sure that there's not. Accessibility, you get some accessibility for free just by using Flutter because things like text widget are accessible, they have semantics in them, but if something's not there, you can use the semantics widget and just wrap anything and tell the accessibility layer that this is, I don't know, a button, for example. Hero, often used in mobile apps. That's the kind of I go to a different screen, but that also grabs a part of the first screen and kind of makes it bigger. That's actually super easy. And so where is it? Hero. You just have a hero widget again with some tag, and then somewhere else you have another tag with the same. I'm sorry, a hero widget with the same tag, and you just say. You don't need to say anything. At that point, when you go from one screen to another screen and it has heroes with the same tag, it will automatically do the transition for you. So it's really no code. And last of all, page view. This is actually how I'm building these slides. So let me just go. The slide deck is basically, this is all of the slide deck. This is the page view of children. The slides are all widgets. And so I can do things like the scroll direction should be actually vertical, and I save, and now I can do this, right? All right, that's it. That's what I have. Thank you for your attention. I'm not sure if we have time for no.
Time for one.
Time for one question.
One question. So can we have?
Oh. Yeah, map widget for Flutter. Not yet, sorry. But we're working on it. Obviously, everyone. So now you probably understand why map widget is pretty hard, because we're not using native views, right? So or platform views. So what we need to do for map widget is actually saying, okay, native view render, and we're going to take this and put it in our OpenGL surface. This is how it's done, and this is non-trivial, but when it will be done, then we're pretty happy, because now everything that I showed you, including the rotation, including padding and everything, will work on the map.
Perfect. Thank you, Filip. That was Filip Hráček. Filip.